Hey guys, Wages Road here. It is June 8th, well, 7th. I guess I'm a day ahead of myself. Anyway, June 8th, 2020. Come at you with a video here. Now, we're going to start here with the Schumann. Obviously, there's a gigantic spike there as you guys are looking at. Well, I should say long duration. It's not really that high in frequency, but it is very, very long, and it seems to be very intense as far as the actual frequency itself. But also something else that's kind of coinciding with this, we have a legitimate sunspot that is now Earth facing, and it's not falling into that what they call Earth facing depletion or something like that is what they call it. It's where I've talked about this for a while. I've observed here for the past, I don't know, ever since I've been doing this, as sunspots tend to come around to be Earth facing, they kind of deteriorate. They kind of, they peter out, they get weaker. And then as they go away from us, they tend to fire back up. But this one doesn't seem to be doing that as much. Not every one of them does it, but that is something that actually has some science behind it that I was not aware of. But there is an actual phenomenon that causes that, and I don't think that they have a clear answer on why. There are some theories about why that does happen, but you would think that, if it's facing us, why is it only doing it when it's facing our planet? You got Mercury and Venus inside of us, closer to the sun. Why doesn't it do it? Why don't the sunspots die off when they come across there? Those are questions that I would have, I don't know the answers to that, but those are definitely questions that I have, because why is our planet so different than the others when it comes to the effect that we have on the sun? Not only does the sun affect us, but we affect it, guys. We're all in a symbiont circle together. I mean, that's what happens. Our whole solar system's connected. We're connected to other planets. We're connected to the sun. The sun's connected to all planets. Guys, even down to satellites. You guys can go look at the CME tracker, and they have IMF lines, interplanetary magnetic field lines, that are attached to these satellites. Because they're connected to the sun magnetically. So that's a connection that everything has. So, if we're connected to the sun, by proxy, anything that the sun's connected to, we are too. So you guys got to kind of keep that in mind as we're, just trolling through time and trolling through our universe like this. This is something that, a lot of people don't actually realize is happening. So that means, that's why when stuff fires off the backside of the sun, okay, and it hits another planet, or it doesn't hit anything, it just keeps going, but it crosses one of those interplanetary magnetic field lines, the connection from a planet to the sun, or anything like that. We're all connected in some way. So it does affect us, even though we might not see it. At least that's how I see it, guys. You guys can have a different opinion. I'm actually grateful for that, because it pushes all of us to, strive to actually seek the real answer on what's going on. But as far as I can see, and as far as the way that I look at it, anytime anything happens anywhere like that, we need to, we got to understand that it does affect us a little, even though we might not notice it. And that's why, and I'm going to quit talking about this, because I have been saying it a lot, because I got pretty much slammed there for a while for talking about, stuff that didn't seem to be that big of a deal. But I'm not going to stop. Okay, this is what I do. This is how I do, and people are welcome to their opinion. Just because those people talk and call me an idiot, because they did, a couple of them did. Wages idiot world is what, and I never talked to these people ever before, not personally anyway. And I still watch those channels, because there's still information there, guys. Information doesn't have any bias, just so you guys know. That's how I look at it. There is nobody that can put a bias as far as whether you like it or not. Information is what it is. And that's how I look at it. And that's exactly how I look at observations too. If I can see it with my eyeballs, it doesn't matter if you like me or if I like you. That observation is still there. And I think that we would all be better off to understand that at a higher level. and it doesn't, get us anywhere else but to a bad place when we start picking at that. So I will stop talking about that. So anyway, as you can tell, guys, we got this big spike. And, prior to this spike, we've been watching as this sunspot has been coming to Earth facing. We started seeing a little bit disturbances here on the Schumann. Not only can the Earth and everything have an effect on the Schumann, but outside influences can, like sunspots. Okay? They can change the frequency of what we're actually vibrating at. It does happen. Okay? It's provably, you can see it with just looking at the instruments and stuff. So, is that what's going on here? Don't know. But it was about the time that sunspot came into where it would be affecting us at a more direct level. And right now, this has actually been ongoing for like, I don't know, 10, 11 hours here. And, the thing of it is, we did have a flare, and that's what we're going to talk about here in a minute, that's outside of this. Okay, it would be basically over here somewhere. That did not affect our frequency, at least not like this did. So it's kind of hard to, pinpoint on what's causing this particular flare here. Now, like I said before, guys, this is what I would consider, I guess we can call it an OG flare, I guess, old school type of thing. It doesn't have the pulsation. Okay, it's solid all the way through. So that was an increase in intensity of that frequency, and it stayed there. It didn't pulse on and off like a wave or something like that. So that is what's different about that. Now, so if you guys were experiencing any kind of, sleeplessness last night into this morning, ringing in your ears real bad, all the above, okay, that most definitely could be part of it. That's a significant spike, guys. That's one of the bigger ones that we see. Back in the day, if you were to see something like this, you would freak out. And you could tell by my tone probably that I'm not freaking out because we've seen this so much lately. And, I got to kind of fight that in my own head. Just because we've seen it so much doesn't mean that it's any less important to talk about. And, it's just as significant as it ever was. So I can't become complacent on thinking, well, we've seen that before, so just not even worry about it. Well, we can't do that. Okay, that's what I'm trying to say. We have to keep the importance where it needs to be at, the focus, which is right there at a spike. That's a significant spike, so we need to talk about it. I mean, that's just what it is. I don't care if there were 1,000 of them. We should talk about all 1,000 of them. That's just what I'm saying. So anyway, you can see how the frequency, again, provably has increased. It is not, not only do we have the 7.83 like I said before, but we got this one here now that is staying. It's right around 13 roughly hertz. Okay, that is not going away. That one stays just as constant as the 7.83. You guys can see that. Okay, and how can you see it? Well, I'll show you right here. Actually, you can see it on both ends, and I'll show you here in a minute. But here's the 783, always stays there. Well, this one is now staying there, and you can tell how this one's starting to, but this one's not quite there yet. Okay, so that's a good way to show you guys that definitely that frequency has increased just by looking at this tool. It's an observation, it's visual, it's right there in your face. You can't deny that the frequency has increased, and it's right there. You cannot deny that. That is an observational proof. That is proof. That is not up for question. It's in your face. It's right there. Now, what's causing it is always up for question. Okay? That's where the conversation comes in. We see an observable fact by this. This is not a tool flaw because this is continual, and it looks just like anything else that we see. So this is nothing that can even be argued that our frequency hasn't been increased. So if people want to tell you that it's not, I would suggest that you question whether or not you should listen to those people, because they're denying what's exactly right in their face. You can't deny what this tool is showing. That's kind of what I'm saying. I don't talk in definites like this, guys. You guys know I don't, unless it's 100% observable fact. That is something you can't deny. You can't say that is not an increase in frequency. You just can't say it. Because if you do, you're, short of calling you a liar, you're just denying it. what you're seeing, or you're trying to push it away so it fits your narrative. Resist doing that, guys. When I say things, I want things as I say to be true too. But I have to tell myself, when I'm looking at something, if I'm wrong, I just need to say that I'm wrong. And that's why I'm saying this, because I'm not going to have an observation that doesn't fit my narrative and just keep trying to make it fit. It doesn't happen that way. It's not how I operate. And other people that do that, guys, just steer away from them. Go away from those channels, because they're not going to give you any kind of truth unless it fits exactly what they think it needs to. So, anyway, that's what I would say to that. And I address that just because I do get a lot of questions, a lot of comments like that. And they're legitimate, okay? I'm not saying that they don't need to be talked about. I just tend not to, because all it does is cause drama. And I won't be a part of any of that. You guys know that already. But anyway, that spike right there, guys. So if you guys felt anything crazy, there you go. Okay, guys, this is back yesterday. This is over at SEEDS, LASCO C2. It's our view from the sun, okay, of the sun. Here's Earth, satellite. We're looking at the sun, okay? Also, keep in mind that the sun itself, the surface of it, is basically the size of that white circle there on the right, and basically kind of like this, okay? That black occulter is there to block the main parts of the light of the sun. If it was not there, we would see nothing but a big bright white light. That's it. The camera has to have it there, or it won't see anything. Okay? That's why it's there. If anybody were wondering that's new here, I like to say that. It doesn't take long to say, and it's easily explainable. So, but this is our viewpoint from Earth. Okay? The satellite's out there about 1 million miles closer to the sun than what we are. Now, what we've been noticing, guys, is a lot of these little ball-looking ejections. Watch what happens right here. Okay? It's really compact. It shoots off the sun. That most definitely was an ejection. It was small. Doesn't seem to be very big. We could catch a glancing blow from it, but would we even notice it? Probably not. So, unless we took it right on the chin. Who knows? But I don't see any problems from that one, just so everybody knows. Now, so we go to the next day, which it would be today, the 7th, going into the 8th. And what we see here, we're going to see a flare. Okay, you see that big flashing? Anytime you see that flash, just stop and look. That's most definitely what that is. We got stuff happening, right? Something else I noticed here on this one, for whatever reason, it did start right at the top of the day. Usually we don't get to see that. Usually it's like 2 or 3 hours, like somewhere between 2 and 6. Is usually the first capture we get of each day. I don't know why that is, whether they take these things down to do maintenance on them, as far as the software and the programming, or what, I don't know. Or maybe they're some sort of download or something they need to do to keep these things updated. Who knows? But I did notice that. Now, what you're going to see here at the end of the day here, you're going to see a little bit of a flare happening. Okay, and it's going to happen there, what looks to be on the left side. Okay, that is right there where that sunspot's at. So we're going to go take a look at that on SDO, because, and also you're seeing this other stuff ejecting out. So what that's telling me is that that's either going off the backside or it's coming at us. Now, as far as the big ejection, as far as going out the side. Now, with that, if that came off of that sunspot, it would most definitely, the flare itself was probably coming at us. But I think there's a secondary ejection going off at the backside at the same time, or close to the same time. And I'll show you what I mean. So, just hang in there for a second here. Okay, guys, this is stereo A. Okay, so Earth would be over here. Satellite's here. And it's looking at the side of the sun from our viewpoint. Okay. So, basically, this would be as if something from our left side was looking at the sun. Okay, if you want to look at it in that way. So you can tell here at the end of the day that something did blow off the backside of the sun. Okay, if you look right there, watch it get bright. It's just now happening. Okay, you can kind of see it over here too. We'll try to stop it here at the end of the day. And see if we can't get a good peek at it. I think we can get a pretty decent peek. Also, guys, don't worry about this stuff. Okay, what that is, those are internal parts of the camera that are reflecting light and how you know that it's that and not something that's out there is the uniformity of what the spacing is and the actual rectangle shape. Okay, these cameras, guys, they're tubes. All right. So looking at it from the side, obviously it would look like a rectangle. Okay, and it would be like this. So what you're seeing here when you see these things down here, you're basically seeing half of the tube. Does that make sense? And why I'm saying half of the tube is because inside of these things, there's baffles that actually turn. Okay, so when it catches it at that specific time and that light gets reflected, it looks like a half of a tube. Basically a rectangle that's kind of got a U shaped on the end. Alright, that's what it looks like. And it's perfectly spaced out. And every time we see these, they are perfectly spaced out. So they look just like the internal parts of the camera. That's what I'm trying to say. Now, if I don't think they look like the parts of the camera, I tell you guys, and I've shown you guys that multiple times. I was fooled by that at the beginning of my channel, a few years back. We were even calling them Kool-Aid cars, if you guys remember. But, again, once I figured out that that was not the truth of what I was looking at, I immediately came out and told everybody, hey, listen, we figured out what that was. That's basically internal reflections of the camera. Because most people think of a camera, they think of something rectangle that they can hold in their hand with a flash over here, right? Or their phone, right? Well, that ain't what these things look like, okay? They're tubes. They're literal tubes about this long, and they got, all kinds of different shapes and stuff on them. So we have to take that in consideration. We cannot be ignorant to the fact that these things do take shapes, and yes, there are camera anomalies. We cannot assume everything we see is something that is just, out of this world type of thing. And a lot of us, and even me at the beginning of my channel, I was that way. I admit it. I was thinking everything was, oh my gosh, look at that, Well, yes, we should be like, oh my gosh, look at that, and then research it, and then if we're shown to be wrong, come out and say it. That's what we do, right? And we want to find the truth. That's what we're trying to find here. We're not trying to find something that fits somebody's narrative. We're trying to get to the actual truth. Now, I could be wrong on everything I just said. If somebody can show me and prove to me that I'm wrong, that is not a camera anomaly, then bring it to me. Let me see it. I want to see it. But if you can't, then don't tell me it's not. That's kind of what I'm saying. So I get a lot of emails and stuff thinking, man, I really, look, check this out, this and this. And I've explained a lot of times that what this is, guys, is internal parts. And it's okay to ask that question. You can ask me every day if you want. But, if you want to, try to convince me that it's something that it's not, then show me. Show me what you're seeing, and show me why you think that. That way, I can learn from that too, if it's actually something I don't think it is. So anyway, that's what I would say to that. But, so yeah, ask me all the questions you want, and please show me where I'm wrong, because I want to know, if I'm wrong about what I just said right there. Show me something that proves to me that is not parts of that camera. And then maybe I'll switch my point of view. That's just what happens. That's what I do. I've switched my point of view a lot of times when I figure out something isn't what I say it is, or what I think it is. So, but anyway, that CME is actually, that looks like a CME that's going off the backside of the sun as we speak. Okay? But we did have a flare, and I'm going to show it to you. Okay, guys, I got you over at NOAA, Space Weather Prediction Center. And this is the solar X-ray flux. This is where I show you guys basically, the solar flare X-ray stuff that we look at. And it's been getting more and more active on this end because we're getting more sunspots. Okay, it's usually where this X-ray flux stuff comes from. Okay, at least the intensification of it, and it is Earth facing right now. So that's why this baseline has went from being down here to up here. Okay, because we're getting more of it in a consistent way. But when you see these spikes right here, that means it had a flare. Okay, it's been popping little ones, and I've been talking about that. Okay, just really small ones, so that it is an active sunspot. It's not busting off big ones, but at any time it could. That's my whole thing here. So we did have a larger one here just a few minutes ago. Well, a few hours ago, I guess. and it looks like it might have got into low-level C class range, which again, most likely isn't going to, it didn't do anything, okay? We didn't really see any effects of it, like physically in the real world here, okay? But it did, look what it did. It did raise our geomagnetic activity. So it almost put us in the storm range for a minute. Okay, now this does happen from time to time. If you get a big flare, the bigger flares will put you into geomagnetic storm levels. All right, that's just what happens. Also, CMEs and obviously solar wind will push this up too. But what we're seeing this time is those are correlating with each other. See how they happened at almost the exact same time? Well, that's why. Okay, that's why you see that. Now, as we get moving forward here, we're going to have to pay attention and see what happens here. If that tends to stay up, maybe there's more activity coming. But the other CME I showed you guys is actually going off the backside of the sun, so it will not affect us geomagnetically. All right. But you can see here's that sunspot that probably did it. We're going to go look at SDO here in a second. But you can also see here when that happened. Look what happened to the solar wind. Boom, went straight up. Okay, that's when all that went down. All right, and just like we would expect, solar wind speed goes up, the density actually comes down a little bit. Okay, usually those go opposite of one another. Like I said, we have to look at our range here. Now, a lot of times you come over here and the bottom one will say 300 and the top will only be at like 400. But right now, as we're looking at it, the bottom is 200 and the top is 500. So you're looking at a 300 kilometer per second increase, okay, as far as the range goes. And it went from roughly, 350 to 500 like immediately. So that most definitely was from that sunspot, I would think, that little flare we had. And just like we would expect, the temperature rose too. Of the plasma temperature. So that's what we've seen there. I do think it was from that flare. We can go look at this. We can see how they're predicting here in 5 days. We're going to have a high dense event from something. I'm not sure what, but that's what they're showing. Okay. I tend to think that that's probably not going to pan out exactly how it says it is, because this thing is never right 5 days out. It will change 5 times in 5 days, if not more. So just know that. It's like the local on the 8s. It gets new data and it changes. So, okay guys, I'm really not seeing any kind of like big flare in your face type of thing. I am seeing some small ejections that's going on. That could be the culprit of what we're seeing in the X-ray flux there. It could be a flare. It could be whatever. I don't know. It could just be the fact that we do now have a decent sized sunspot looking dead at us. Okay. But that wouldn't explain like a spike. There could be a flare inside of this that I'm not seeing. And you can see obviously the electricity and everything going on with this. It also has something what they call, I read this over at spaceweather.com, a scorpion tail. And it's basically, you see these loops, right? Well, the scorpion tail, they call it a scorpion tail because that's what it looks like, all right? So you'll have a sunspot, say, right here, and it'll have like basically looks like a little scorpion tail, I guess. Kind of like one of these, right? Well, what happens is, eventually, like I've talked before, that shape will end up being, here's the sunspot, it'll kind of come out like this, and it starts getting closer to each other, like that. And eventually, when these touch, it's basically it explodes right there. And then that's a filament is what that is. Okay? So that filament will explode off, and that's what would give you the issue, geomagnetically and all that. So that would basically be like a big CME, a filament release, okay, a solar storm type of issue. But that's what they call it, and I didn't know this till the other day when I was reading it over at Space Weather. They call it a scorpion tail. But it's acting just the same as these loops that we typically see on the sunspots. Okay, they usually loop up like this. And I've shown it before, they usually end up start to look like this, right? And then eventually this area here will get close enough that they'll touch, and boom, that filament will explode off. All right, so basically it's like a big short, I guess, if you want to, but you know, if you really want to get it to a basic level, that's really kind of what it is. Most people, you know, remember the old movies where they would jump start a car by pulling the wires out from underneath the ignition and touching them together. That's kind of what's happening there. Okay, you see a big spark and boom, there it goes. So if you want to think of it that way, you can. It's a good way to remember it. I know that. Now again, guys, just because I'm not seeing it doesn't mean that it ain't happening. Well, it looks like Mike and Cindy are doing a show. Yeah, we'll watch that. Okay. Anyway, now look, we are seeing, and this could be that thing that blew off the backside. Watch right in here. Okay, right there. You see that? That plasma left the sun. Okay, so when it did, that made it a CME. So, you know, a lot of times that stuff will go out and the sun will recapture it. It almost looks like a CME that gets sucked back in, because essentially that's what's happening. The plasma is going out and it isn't able to leave the sun. The sun recaptures it. So it's really not a CME until it actually leaves the sun. Just so you guys know. Now, here's that other sunspot that was really, really big before it rotated through. Again, Earth facing, then it kind of petered out. It looks as though it might be trying to regenerate here a little bit. Could be. But this sunspot here doesn't look like it's trying to peter out at all. And it's almost right in front of us. Okay? And you can tell, see, if you look around the edges here, you can see how it's darker around the base of it. That is typical around a sunspot. Now, the equator of the sun is basically here. We sit just to the south of the equator. If you took the equator of the sun and you expanded it out through our solar system, that's what's called being below the ecliptic. If you're above that, you're above the ecliptic. If you're on it, you're on the ecliptic. Basically, it means you're in the same area of the equator of the sun. That's all that means. Okay? Whether you're above or below, it's just a way to designate and navigate and tell people direction of our solar system. Okay? That's why they use those words. It's just a way to be able to tell what we're looking at directional wise. So if we're below the ecliptic, that's what that means. We're below the equator of the sun. And that's where we're at right here. So as this thing gets right in front of us, and it will, because the sun's rotating this way. And something else you guys need to understand, believe it or not, the sun rotates at different speeds at the top, at the poles, than it does in the middle. Okay, a lot of people don't realize that either. So this one's going at a different speed down here. So that's why sometimes we see them, they kind of look like they might be moving at a slightly different speed. And it's actually happening, okay? I know that some people can't wrap their brain around that, but that's really what's going on. So I don't really talk about that much, but it does affect some things on the sun, the difference of speed there that they're moving. But anyway, I am going to go ahead and end the video here, guys. I may come back a little bit later, maybe tomorrow. I've been just trying to rest. I've been out in the heat all week, and it's been really, really brutal here lately. So I'm sorry if my video production has gone down a little bit, but I got to take care of myself a little bit too. So, and spend time with my family whenever I can. So, but anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.